While Earth's climate is mostly influenced by our actions here at home, one extraterrestrial force plays a role: the sun. The staff at the CSUN Solar Observatory routinely track these behaviors through a unique 50-year-old imaging process to provide data for scientists all over the world. The research has been led by Dr. Gary Chapman, now Professor Emeritus for the Physics Department for just under 20 years. Chapman joined the crew that ran the observatory in 1969, months after it was built near the Van Norman Reservoir in Granada Hills. However, the '71 San Fernando earthquake rendered the telescope too expensive to repair. So with the help of grants from NASA, Parsons, and other funding from the university, Chapman was able to get the observatory telescopes moved to CSUN, where they sit in the orange grove today. These telescopes are over 50 years old, so their imaging process is different than an average camera. Rather than capturing a single snapshot, the telescope uses a technique called a drift scan to map the entire solar disk.
So it's just 512 photodiodes lined up. It's about a ½ inch long gadget. And you sweep that across the sun and letting the Earth do the sweeping, because the Earth's rotation is quite smooth, and so you have a very nice, simple image.
The telescope isn't just a one-trick pony. It uses specialized filters to study sunspots and faculae. Sunspots are areas that are cooler than the surface of the sun, while faculae are hotter. These spots are caused by changes in the sun's magnetic fields generated inside the star. These spots don't look like much, but enough of them can have a real impact on the energy the sun puts out, and we can feel the effects here at home.
Without the sun, we'd all freeze to death. So, small variation to the sun over a long period of time can affect the climate.
That's why Dr. Chapman and the observatory staff keep a constant eye on the sun. With a record spanning decades, they are able to refer to the sun's past solar cycles to make sure nothing out of the ordinary is happening.
You want to make sure that what you think is happening with respect to sunspots and these faculae is good for the long term. I mean, you can see for maybe one solar rotation, which is a month, a couple solar rotations, you say, oh yeah, it looks great. We get a good match with the spacecraft. But what about last solar cycle? Was the sun behaving the same way?
At the observatory, no news is good news. If the sun is behaving as expected, then there isn't much to worry about. However, if the sun appears to be doing something unexpected, the staff at the observatory will be the first ones to spot it. Other than monitoring the sun, the observatory provides useful data for scientists all over the world. The images generated are analyzed in-house and then made available for the scientific community to use. The records gathered are a mere sliver of the sun's total lifespan, but the work the team does builds an important and ever-growing snapshot into the life of our planet's star. From the Orange Grove, Eric Davidson for the Sundial.